This meeting is being recorded.
Hey guys, Kenna here. So today we're going to be looking at the layers of the atmosphere. If we're going to go ahead and talk about air pollution and climate change, we need to understand the structure of the atmosphere so that we can better understand what's happening and where in our atmosphere it's taking place. So let's go ahead and jump in and start looking at our essential questions. Number one, what is the composition of the atmosphere? So what is it made of? Number two, what is the difference between weather and climate? You may have gone over these terms in middle school. We just want to make sure you have them clear. Number three, what are the 5 layers of the atmosphere? Number four, what is the relationship between temperature and altitude? So as you go up, what does temperature do? It may be a little more complicated than you originally thought. Number five, what is the location of ozone in the Earth's atmosphere? The primary location. You can get it in other layers, but it's meant to be in one particular layer. And number six, what is the relationship between atmospheric pressure and altitude? Now, before we get started, the atmosphere is something that I think we overlook a lot. We can't see a lot of the air that we breathe, and so we forget about it. Okay. If you can see it, it's something you should typically be concerned about, right? So, at its very simplest, the atmosphere is the layers of gases that surround a planet or moon held in by gravity. Okay. And that's not fully true, but yes. Okay. So, it's kind of this ocean of gases that sits above the surface of our land. Now, we live at the bottom of this invisible ocean called the atmosphere, these gases that are surrounding our planet. And it's primarily made up of two specific gases, nitrogen and oxygen. And these account for 99% of the gases in dry air. However, it's that 1% that makes a big deal in terms of what we start looking at with respect to climate change. This includes argon, carbon dioxide, helium, neon, and other gases that make up tiny little small portions. Okay. So, as we go through and start taking a look at the composition of our atmosphere and the layers and how those layers are set up, we need to be thinking about why small changes in those composition numbers can have a pretty big impact in terms of how the atmosphere functions. Okay. There's a great ed puzzle we'll go ahead and watch as part of this. And so we want to make sure that you understand the structure and the layers so that you can better understand the features of those layers that provide the traits of our atmosphere. So again, the atmosphere is the envelope of gases that surround our planet. It consists of 5 major layers, and the atmospheric gases are concentrated in the lowest layer of the atmosphere, the troposphere, which is the one that we live in. In the troposphere, 50% of the atmosphere lies below 5.6 kilometers in altitude. 90% of the atmospheric gases rest within only 16 kilometers of the Earth's surface. So it gets pretty thin in terms of gases as you go further and further away from the surface of the planet. And that's why heat transfer is impeded at higher altitudes. And that's also why the atmospheric pressure decreases. One of our essential questions. The atmospheric pressure decreases as one travels out into space away from Earth. Now, when we're thinking about these layers, if it's only that first 16 that really have all the gases, hopefully you recognize that that's where most of the air pollution is going to occur as well. Now, air pollution occurs when harmful or excessive quantities of substances are introduced into the Earth's atmosphere. Now, that does not just have to be man made sources. Nature actually produces some atmospheric pollution as well when we start looking at volcanic eruptions, for example. Okay. If you have major dust storms, you can end up having air pollution in that form. So there are things in terms of especially debris and certain amount of gases that can be caused naturally. We're going to focus primarily on human caused air pollution, but it's important to recognize that there are naturally occurring ones as well. So what sort of things are we talking about? Sources of air pollution include gases, ammonia, carbon monoxide, sulfur dioxide, nitrous oxide, methane, CFCs or chlorofluorocarbons, just to name a few. They include particulates, both organic and inorganic, and they include biological molecules. Now, let's take a look at the actual gas mixture that we're having that makes up our atmospheric composition. Now, atmosphere is a mixture of gases, dust, water vapor, and it changes depending on where you're at, what time it is, what kind of weather you're having. And so, again, 78% of our atmosphere is nitrogen. I know a lot of people think oxygen's the primary component. It's not. Nitrogen is the primary component, with oxygen being second. And then 1% of that is our other trace gases that we're going to go ahead and talk about. Okay. When we start looking at this expressed as dry air volume, nitrogen actually makes up 78.1%, oxygen about 20.9%, argon is the next largest at 0.9%, with carbon dioxide and others being less than a tenth of a percent. So when we start to think about this, when we start introducing carbon dioxide that wouldn't normally be there, you can upset the balance of gases um, in the favor of climate change and away from our overall health. Because remember, we need that oxygen in order to survive, and we're converting that into carbon dioxide at faster rates as the population begins to climb. And we have fewer trees due to deforestation, which is limiting the capacity for the planet to go ahead and convert that carbon dioxide back into oxygen. All right. So, again, with middle school, you probably learned about weather and climate. I just want to reiterate those two terms and how they're different just to make sure you understand them. So, weather describes whatever is happening outdoors in a given place at a given time. Weather is what happens from minute to minute. As I look out my window right now, the sun is out, there is no rain in the sky. So, you may think that this is a sunny place to live. But we're in Eugene. It rains a lot. Okay. The Pacific Northwest is known for having a high amount of rain. It's not raining right now, but that's because of the weather. The weather is changing constantly. But our climate is the average weather in a location over a long period of time. And yes, we do live in a wet climate that has a lot of rain. So, a place that doesn't get much rain over many years could have a dry climate, but that doesn't mean it's never going to rain. So, it can still have wet weather. A place where it stays cold for most of the year would have a cold climate, say up in Alaska, but it can still have hot weather. It can have a hot day. And as we start talking about climate change, you may be having more of those hot days than originally, historically. All right. So, again, weather includes daily changes in temperature, precipitation, barometric pressure, and wind conditions in a given location. You get the weather report on the news every night. What is the weather supposed to be for a given day? Climate, however, includes average. And because it's averages, it's over long periods of time. So, average weather conditions like regular weather sequences, seasonal changes, winter, spring, summer, fall, special events like tornadoes, floods. Climate tells us what it's normally like in a place over time. So, ecosystems within the same biome exhibit the same climate, but can have different weather. Now, we mentioned that there are 5 layers of the atmosphere. I'm going to do an overview of each one of those layers here as we go ahead and try and finish out. The bottom layer, down by the surface of the Earth, is the troposphere. As we go upward, we're getting farther and farther away from the surface. So, next going up is the stratosphere, and this is where a lot of important weather occurs. And this is also where we're going to start looking at the ozone being. Then you get the mesosphere. Remember that prefix from your biology days, Mesozoic. Meso means middle. Thermosphere is next on top of that. Obviously, you can see that this has some impact or something related to temperature. And then exo means outer. So exosphere is that top layer before you get into the solar wind, and you can't distinguish our atmosphere from outer space. Okay. All right. So here are those same layers again. Okay. And I don't want you to think that, oh, they're perfect. They're all the same thickness all the way up and nothing ever changes. Remember that the Earth's atmosphere is actually a dynamic system. Um, as we go ahead and look at all these different layers, the average temperatures can vary. Okay, they're not always fixed at a specific temperature, and there are differences depending on the absorption of incoming solar energy. So, if you have a solar flare, there's more energy coming in, and what does that do to the atmosphere, and how does that get filtered down to Earth, etc. The other thing I wanted to kind of point out is that there are these boundaries in between the layers. And it's interesting because they call them pauses. This is the tropopause, the stratopause, and the mesopause. Okay, these are showing that you have this kind of transitional zone where the normal properties in that particular area stop. And you'll notice that we get this kind of straight up and down line where it's not really changing anymore. So any decline or change or increase in the pattern of temperature, pressure, etc., kind of pauses. So that's why we use the term pause. So let's start at the bottom and look at the troposphere, and then we'll move through the layers going outward. So closest to the Earth's surface, we have the troposphere. Tropos means change. This layer gets its name from the weather that's constantly changing and mixing up the gases in this part of our atmosphere. The troposphere is between 5 and 9 miles, 8 and 14 kilometers thick, depending on where you are on Earth. It's thinnest at the north and south poles, and thickest typically around the equator. The troposphere is the lowest and densest layer of the Earth's atmosphere. One of the things that we're going to look at as we go ahead and start focusing on a lot of our weather patterns and changes and the environmental impact of air pollution is what happens here in the troposphere. And one of the things I wanted to go ahead and highlight for you here is what's known as a temperature inversion. This is a reversal of the normal behavior of temperature that you saw in the previous slides, in which a layer of cool air at the surface is laid over by a warmer layer. And under normal conditions, air temperature usually decreases with height, but in this case, it's inverted, which is why they call it an inversion layer. And so this can actually trap in more of those air pollutants and make the conditions even worse. So we'll talk more about that later as we start looking at inversion layers and air pollutants. The next layer as we go up from the troposphere is the stratosphere. This is the layer, uh, strat comes from the word layer, and of our atmosphere, it actually has its kind of own set of layers. And this is the layer that it typically includes the ozone layer, the one that protects us from those harmful UV rays. There really are no storms or turbulence here, and means that the air doesn't mix up as much, which is why it's able to go ahead and stay more in layers. So typically, heavy air is at the bottom and warm, lighter air is at the top. And that's the opposite of how the layers work in the troposphere. We're typically warmer at the bottom as we're closer to the surface, and it cools as you go up. But in the stratosphere, it actually is going to go ahead and warm as you go upwards. This is where a lot of those long plane flights take place because there is less turbulence here. And so when you send, those, over the ocean aircraft, those typically will like to fly at these higher levels due to the lower amount of turbulence. This layer is about 22 miles or 35 kilometers thick and is where we find that important ozone layer again. Now let's take a little bit at that ozone layer before moving on to the other layers. So ozone, if you're not familiar with it, is O3. The oxygen that we breathe is typically in the form of O2. And so this is a much rarer and less stable type of oxygen molecule because it combines those three oxygen atoms. Ozone is important because it absorbs ultraviolet light in the stratosphere, but pollutes the air if you find it in the troposphere. This is actually one of the primary causes of what's known as phytochemical smog. This layer is very thin and has 3 ozone particles for every 10 million air molecules. So it's thin. And unfortunately, humans have thinned the layer, especially above the Antarctic. We have the hole in the ozone layer. Okay. Now, when I was in high school, it was getting really big and there was a lot of concern. But due to political changes and the willingness of people to stop using, especially molecules like CFCs, we've been able to give the ozone hole some time. And being resilient like it is, our planet has been able to kind of shrink and begin to heal that hole in the ozone layer. Okay, so after the ozone layer, which again is part of that, uh, the stratosphere, we're going to go into the mesosphere. Now, meso again means middle, and this is the highest layer of the atmosphere in which all the gases are mixed up rather than being layered based on their mass. The mesosphere is about 22 miles thick, 35 kilometers, but the air is still pretty thin. So you wouldn't be able to breathe up in the mesosphere, but there is more gas in this layer than there is in the thermosphere, which we'll get to here in a minute. This is the layer where you start seeing the burning up of meteorites. Okay, and so when you watch something like the Perseid meteor shower, which if you've never seen it, I'd encourage you to do so. This is where it occurs. Have you ever seen a meteor shower where they kind of see it? If you've ever seen a shooting star, this is typically kind of what you're seeing. These are meteors that are burning up in the mesosphere. The meteors make it through the exosphere. Begins again, there's very little actual material in the exosphere. Um, and then once they pass through the thermosphere, they begin to warm up. And again, they have minimal trouble there. But as they come into contact with the higher amount of gases that make up the mesosphere, uh, they begin to heat up, and the friction causes the glowing that is the streak across the sky that we think of as a shooting star, or a meteor shower. Okay, so after the mesosphere, we're moving on upward into the thermosphere. This is the layer of the Earth's atmosphere that's next after the meso, but before we get to the exosphere. Thermo means heat, and the temperatures in this layer can reach as high as 4,500 degrees Fahrenheit, so hot. If you were to hang out in the thermosphere, though, you would be very cold because there aren't enough gases in terms of the molecules to actually transfer the heat to your body. This also means there aren't enough molecules for sound waves to travel through. So, this is the first layer of the atmosphere where you can start screaming and nobody would hear you. Not that you would want to be up here without any protection anyway. Um, this also means there aren't enough molecules for sound waves to travel through. So this layer of the atmosphere is about 320 miles thick. It's about 520 kilometers, and that's a lot thicker than any of the inner layers we've been discussing, but won't be as thick as the exosphere when we'll talk about later. In this layer, we have the International Space Station, or the ISS, and you can see from the ISS that, yeah, we have an atmosphere, but you definitely feel like at this point you're in space. So you'll find low Earth orbit satellites in this area. A lot of our communication satellites will be in the thermosphere because, again, this is a really thick layer. There's a lot going on there. NASA's SAGE 3 ISS program will measure aerosols, or tiny particles that are in the air, and Earth's protective layer of ozone and other trace gases that may make it up into the thermosphere. This space station's orbital inclination provides the ideal view for consistent ozone measurements. And so we actually do a lot of work monitoring the gases that exist in our atmosphere. And so a lot of the data that we have actually comes from NASA and from the ISS. And so a lot of research done in this particular area. And again, this is where we start seeing a lot of our actual satellites that are going to help us communicate and monitor things on our planet. The last and final layer that we need to go ahead and view is the exosphere. Exo, like exoskeleton, means outside, which should make sense because this is the last place we actually see noticeable atmosphere before everything becomes mixed up with the solar radiation that is in outer space and the solar wind coming from our sun. This is the last layer that separates us from outer space. It's about 6,200 miles, or 10,000 kilometers thick, and that's almost as wide as the Earth itself. The exosphere is really, really big. The exosphere has gases like hydrogen and helium, but they are so spread out. There's so much empty space between them. There is no air to breathe, and it's incredibly cold because you are pretty much at outer space temperatures. Okay, which you're talking about outer space being about 3 degrees Kelvin, or negative 207 degrees Celsius. So super, super cold. All right, so what are the key takeaways we need to make sure we have from today's notes? One, Earth's atmosphere is made up of a combination of gases. Most of it's nitrogen, about 78%. Then we have oxygen, followed by argon, and then the rest of them. And there are some of these trace components like CO2 and water vapor, which vary a lot depending on where you are and what time it is, what season is, etc. But they play a key role when we start looking at climate change, as these are greenhouse gases, and that's going to change the functioning of our atmosphere. Number two, the atmosphere is divided into the exosphere, which is the outermost. Going inward, the thermosphere is next. These are the two largest of the spheres, exo being the largest, almost the thickness of our planet. Thermosphere having incredibly high temperatures, but pretty thin gases, so hard to transfer them. The mesosphere, this is where we're going to go ahead and see meteor showers. The stratosphere, which is where we're going to go ahead and have those settled out layers. One of those being the ozone, the important ozone layer. And then we have the troposphere, the changing layer that has all of the weather that we're used to. This is the layer that we're in. Number three, boundaries between these layers are defined by changes in temperature and height. And we typically have a little thin layer in between called a pause or a transition layer between the two layers. Number four, pressure decreases exponentially. So exponentially with altitude in the atmosphere. And number five, our knowledge about the atmosphere has developed based on data from a variety of sources, including direct measurements from balloons and aircrafts, as well as remote measurements from satellites. Okay, guys, so I hope you have a better understanding of the atmosphere now. That's what I've got for you today. Stay healthy, stay safe, and I'll talk to you soon. Take care. Bye bye.